So first thing our run method will do is call our load content method and our initialize method. So there we go, load content and initialize. Okay, and after that we're going to declare a few local variables. The first one will be of the type double, and let's call this total time before update, and initialize it with 0. And another one called float, not called float, but a type float. Let's call this previous time elapsed, which will also be 0. Then our delta time, also 0. And total time elapsed, also 0. Okay, and now there is a utility class in the SFML.system namespace called clock. And we're gonna need that. So we're gonna create a new instance of it. And what clock is used for is to, it's basically similar to the stopwatch class that is included in the .NET let me think, .NET diagnostics, I think, diagnostics namespace. It works very similarly. What it is used for is to measure the time that has elapsed. Basically, what we could do is just start this clock, get the time value that has elapsed, then reset the clock at the end of the frame, and start it again and use this value as our delta time. But I tried it out myself and it's not very reliable. In fact, it's really not reliable. So we cannot just use that. We're gonna do we do use the clock class, but we're not gonna restart it every frame and then just measure the time this way. In fact, we're not gonna restart it at all. We're gonna start it once and then calculate the delta time, which is a very simple subtraction. All right, so what our game loop lacks so far is an actual loop. So let's do this next. So let's create a while loop, and our window, our game window, has a property called isOpen, which returns true, obviously, if the window is open. And this will be our condition for this while loop to be executed. So as long as the window is open, keep doing whatever is in here. Yeah, that's one thing I need to explain first. SFML uses several event systems to handle stuff like user input, keyboard input, joystick, joypad input, and even like resizing the window, stuff like that. It uses event systems. And to handle all these events every frame, we need to first call this method inside the window instance called dispatch events. Okay, we just need to do that because of SFML reasons. All right, so to get our total time elapsed, we're going to access our clock that we just created. Oh, and clock, as soon as you create a new instance of clock, it automatically starts measuring time. It will automatically start like a stopwatch. Contrary to a stopwatch class. The stopwatch class, you would have to basically start it manually, but clock starts automatically. So access our clock that we just created, and in there's a property called elapsed time, which returns the type time, which is not what we need. But inside there's a method called asSeconds, which will give us the total time that is elapsed in seconds, and this is what we want. Now, to calculate our delta time, we just basically need to say total time elapsed minus previous time elapsed, and then update previous time elapsed to total time elapsed, right? So when we start, previous time elapsed will be 0, of course, because time hasn't elapsed yet. And then we get the time that has elapsed and calculate delta time by just subtracting the time that has elapsed by previous time elapsed, and then previous time elapsed will be total time elapsed. Makes sense, right? Okay. Now calculate total time before update. This will be done by simply adding delta time. So we just sort of accumulate this value. Each frame we add the time that has passed within this frame to total time before update. And as soon as total time before update reaches a certain value, we want to update our game logic and render stuff. So let's create an if statement. If total time elapsed is greater than or equal to the value that we defined right here, time until update. Why does it say target FPS does not exist? I think once I compile, this will be okay. As soon as total time elapsed is greater than this value. Why doesn't it find it? Okay. Once it's bigger or equal to this value, we want to of course call our update method and pass our GameTime property. Of course all of our child classes of this game loop will also have access to GameTime, but just to make it more convenient, we will have the GameTime also as a parameter in this method, because we're just going to use it a lot when we actually code our game. But before we can call our update method and pass it our GameTime, we have to actually update our GameTime, because we haven't done that yet. So let's call the update method in our GameTime property and pass it its new values for delta time and for the total time elapsed. Okay, and delta time, for delta time we're gonna pass, we're not gonna pass this delta time here, because this delta time only refers to the time that has passed within this total frame, but instead we're going to pass total time before update, right? Because total time before update will be 0.016666 when we get into, well, when this condition is met, right? But I just realized that I made a mistake. I declared this as a double for some reason, but we want this to be a float as well. Okay. And of course, total time elapsed is another value we need. We could just pass it this value, but if we want to be really, really precise, we should actually pass it this value, because some time, some really small amount of time must have passed since this line and this line. So if we want to be really precise, we have to pass this as the total time elapsed. But we could also pass this. We don't have to be this accurate, but just for the heck of it. Okay. So, and then after that, just reset total time elapsed to 0. Okay. So that in the next frame, it'll have to, oh, sorry, no, I mean total time before update back to 0. Right, so it'll have to store the amount again until it reaches the time until update, and then it will update again. Okay, so this is looking good so far. And after the update, we want to do the rendering. And before we can do rendering in our render window, we have to call the clear method in our window. This is just an SFML thing. Before you can render stuff, you'll have to clear everything that is inside the window. Oh, and of course, we're gonna need our clear color property for that. So basically just make our window be displayed in whatever color we passed for window clear color. And after that, call the draw method and pass GameTime as well. And after that, call window.display. Window.display is basically just a method that actually displays what you said should be rendered. Okay, I think that's it. I think we're done. Actually, there's one more thing we need to do inside this class, but we're gonna do that later for demonstration purposes. You're gonna see what I mean by that. Now we can create our class that'll actually be our game, or at least the starting point to our game. So for that, create a new class. Actually, I'm gonna create a new folder and call it I'm gonna call this game. Inside that folder, add a new class and call this I'm gonna call this tuto game or tutorial game. Call it whatever you want to name your game. Okay, and again, we don't want to use we don't want this to be in a different namespace, and we're going to use the SFML namespaces. Let's just include all of them, because we never know what we're going to need in our actual game class. And system. Okay. Now, of course, we need to derive from our Gameloop abstract class. And now it will say the constructor, it won't work, because what we need to do is when we call the constructor of this tutor game class, that constructor again has to call the base constructor, which means the constructor of this abstract class, and pass it its values that we want. And for now, we want the dimensions, the size of the window to be defined at least the default value of that be defined as a constant. Whoops, not up here, but inside here. So let's just use a constant, and again use an unsigned integer because this value cannot be negative, and call it default window width. And I'm gonna just say, well, 640, and default window height 480. Okay, and we're just, when we call this this base constructor, we're just gonna pass these values, these constant values. Oh, I just realized that I misspelled default. There we go. Default height and the title. Let's just pass it whatever you want your window title to be. You can also define this as a constant right here. Actually, let's do that. Oh, I forgot the constant keyword. Well, that's what happens when I'm talking and typing at the same time. But I'm gonna get used to it. Window title. Okay, and pass it this value. And also what we need is a clear color, and our color class has a few static properties inside, which will return certain colors. And I'm just gonna use blue because my favorite color is blue. Okay, so now our constructor of TutoGame, or whatever you called it, will call the base constructor and pass it those values. All right. The next thing we need to do is actually implement all of our abstract members, meaning the methods that we created in our Gameloop, in our abstract Gameloop class. Remember, we created a few abstract methods for loading, initializing, updating, and drawing. I don't want this. I just use this functionality of Sharp Develop to automatically implement all of those abstract methods. Of course, Visual Studio can do this as well, but you can also do this manually by just using the override keyword. Okay, I don't want to throw exceptions. I don't need to do that. Okay, perfect. Save this real quick. And now, what we can do now is actually create an instance of our TutoGame, or whatever you called it, in our main method that is called when we start the application. So let's go TutoGame, TutoGame, new TutoGame. We don't have to pass it anything, and then we call TutoGame.run. And assuming we did everything correctly, which in most cases is not the case. In most cases, there's some little oversight in your code, and it won't run, it won't compile, but I hope that in this case everything will be fine. So let's compile and run this. And it failed. Let's see. Oh, of course. I forgot. I corrected this type, but forgot to actually make the DNF. Okay, so that's a very simple mistake. I expected something more, something heavier. Okay, let's try it again. All right, I just got an exception because I forgot to do one step, and I expected Sharp Develop to act a little differently. Remember when we added all the external libraries into our folder by just copying it? Well, actually, Sharp Develop doesn't refresh its solution, and it doesn't know about these DLLs that we copied into the folder. So instead, what we need to do, sorry for the mistake, is I think Visual Studio actually automatically refreshes it and automatically adds those. But I'm not sure about that right now. But what we need to do is actually go to add an existing item. Whoop. There we go. And now that we're in this folder, go to all files so that we can actually see those. Select all of them and then open. And now we can actually see them here in our solution. So sorry for the mistake. Okay, but there's one more thing. We gotta set those up. Because when we build, when we compile and build our application, it is a debug or a release folder is created, whether on what version we're building. And these DLLs need to be copied automatically into this new folder for this to work. So we're going to select all of these, and there's a properties panel in your IDE. In Visual Studio, it's also called properties. And there's a setting called copy to out, and we want to do that with the newest version always. You could also say always in this case, because it doesn't really matter. But if we want to be correct and precise, we choose preserve newest. We're gonna do it for all of these. Excuse me. And preserve newest. Preserve newest. Preserve newest. Preserve newest and preserve newest. And I think that's it. Let's we don't need to save, right? Okay, let's run this again and hope that it works. Perfect. We got a game window in a blue color, just as we expected. Perfect.